explain main theme of sandbox, a bridge between academics and all. And I'm here to introduce Mr. Abhinav and Mr. Mitul. They are here to answer your queries in flat circuit.
Some background noise is coming, Divya.
Um,
Yeah.
it's from Midul, sir. Midul, can you be on mute for some time, please?
Yeah. Just see what is the latency is happening from your side, Vidhu.
Okay.
Yeah.
Divya, you can continue.
Yeah, let them start. Slide. Hi, bro. Hi, now. Can you start your flat subject?
So the point how we take a session is like Divya. So we'll take a topic name. So you have a lot of topics in your curriculum. Right? So you pick up a topic that you want to have a clarification on. So we'll keep it interactive, like question answer model. So if it is a monologue, people will get disconnected. Okay, that's how we can manage. Okay.
Yeah, Abno, can you explain Turing mission? Mitul and Abno, can you explain Turing?
Anyone, Abhinav,
Help,
people.
help me to gain Turing mission knowledge.
Yeah.
So, how can I explain my? Do you
So
have?
just a background of what is Turing machine, Abhinav. Like how should we understand something like can you compare it with something we already know so that we will get to understand it very easily.
You can help by showing previous question papers and giving some solutions to them also, no? With introduction.
Okay. I think Midhur will explain the Turing machine because he knows more analogies than me, as he said
So,
they are taught in this college.
okay. Mithul, do you have understanding of what is Turing machine?
We will check the pattern checking overview of the flag.
Yeah. So you can come back later. You can just have the point ready. So Divya, you can move on to the next question. So by the time Mithul prepares his answer.
Yeah, so you can start with previous question papers you are from unit 1 and you can explain now. Like, yeah,
Okay, just give me a sec. Yes, Ketan, wait. I will see, take out the old question papers and I will like start explaining them.
Okay, we can have the chat with the questions ready so that the organizers can prepare the answers. So if any other topics needed, just type in the chat, please, students, whoever joining.
Can someone confirm if they can see my screen?
Yeah, yes, Abhinav.
yes, Abhinav, it's Abhinav.
Okay. So let's start the with the 7 marks questions. Here in the second question, sigma equals to AB. So we have to use the alphabets AB any number of times to generate a language. And the A bit he asked about the DFA that accepts any string with the AAB as a substring. So the process of DFA to construct a DFA diagram is to identify the language first. the so we have to identify the language. That means the strings that are present in the language that have to be accepted by the DFA. And then according to the question that we want to have this string as a substring of our as a substring in the language. So any combination of a, B letters which has this sequence as a substring comes under the language L. So wait, I will just type in here. So the language would be ABB. This is the basic string, the string he asked. And apart from this, any combination of a, B letters along with this is acceptable in this language. So A is extra here. So this is acceptable because we have the string A, as a substring of AAA, and also and the list goes on like this. So first we have to construct the DFA for the first string, that is the basic string. So in the Google Meet, can't we have the
Tell me, please.
annotation features here to draw on the screen like that?
I think it's not supported. You can just type in,
Type. Let me
or
see.
you can open Paint and you can try to draw with that.
Okay, sir. Then I'll try that. So the screen is visible, right, sir?
Yeah, it's visible. You can tell.
So the first we have the string he asked is this one. So in every string we have to use this one, and so we construct the DFA for the string which has this string as substring. So first we construct for only this particular string, and then we extend it to the other strings which contains any number of a combi with by having this string. So first let's say the state Q0, and on seeing A it travels to the next state Q1. So on B, sorry, on A again the state changes like that. For 6 states we get six characters, we get 6 states.
So Divya, please acknowledge if you are able to follow that.
Yeah, sir.
Uh, I should have read so much small. WAB, yeah, and Q5, Q6. Those are okay. So I messed up here. So we'll get all at most 7 states, I think. Yeah, Q0 to Q6 that accept the that accepts the string double A B. So first we have construct the DFA for this, and after this we extend it to by for any number of A's or B's like that. First we will get the DFA for which accepts this particular string only. So if we give any other input extra, like here starting with B or ending with A, it doesn't take the input. Okay. So at the first we can have without the going to transition. Oh, shit. So without the transition, we have to transition to next state only if we get 2 years continuously. Undo. So it's like so wait, let me show you. So we traverse for this particular A to here, and then we for second A we traverse to another state Q2. We for 2 years we traverse the change the states. So only if next we change the state only if we get to Q3. That is if we get only B. So if we get A, we should stay in that state only. The logic behind this is because we want the string only if there are 2 A's followed by a B. So we got 2 A's, and only if we get a B, we go to the next state. If we get another A, we just stay in that state only, and that state will not be accepted in the final DFA. So in likewise, at the last also Q4, Q5. So let's say this is the final state that is represented by two circles around the state. So we traverse if there are 2 B's, and if we get a A here, we just stay in that state only because we don't want any string which has an A after the B. So I think this is the best I can explain here by drawing like this. Sorry.
Okay. Anyone else would like to add any points to what Abhinav has discussed? Okay, once Mithul joins, I think we'll get more information on that. So, Divya, you can move on to your next question. Or do you have any questions in whatever Abhinav discussed?
Yeah, sir, it's fine. If it's possible, he can explain pumping lemma. CFG.
CFG pumping lemma.
And if it's possible, push down automata also.
Okay, wait. I will say about push down automata by taking some example. So let's take the example of 5B questions, which is 8 marks. Construct a PDA for the PDA that accepts L equal to 0 power n, 1 power n. So what he basically asked is to design a push-down automata which has same number of zeros and same number of ones, which are that means the same order. Zeros are followed, ones are followed by zeros. Okay, first we in any we see a DFA or the PDF. First we identify the language so that we get an idea for which we have to design the design. So let's say L equals to, he said 0 power n 1 power n, and n greater than should be greater than or equal to 0. So the language would be if the 0 1 and double 0 double 1, triple 0 triple 1. So for every both the zeros and ones are of the same number, and ones are always should be followed by zeros. So we shouldn't have a string which starts with 1. Um, and yeah, and again there shouldn't be any zeros which comes after the ones. So this kind of strings are not accepted, which they should be followed first. There should be zeros and they should be followed by ones, and they both must be equal in the same number. And so in PDA it's PDA just like a DFA, but we use a stack to store the data elements, and always the stack top. That means at first won't be any element inside the stack, so we denote with the Z naught, and will be looking at the stack top every time when we transition from one state to another. First we take the basic string that is 0 1, and we can accept the PDA using two ways. That is, we can empty the stack. That means when we start with Z naught, even after the completion of the reading of string, also we should be looking at the Z naught on the stack. Another way is to, like DFA, we will design a final state. So in this we will see by using the empty stack. So let's say the initial state is Q naught and the input is 0 and the stack top is Z naught. And this is the notation for transition in PDA. First we will write the state and then the input symbol is this one, and the stack symbol. So if we get these, if we get zeros, we will push it into the stack. How we will compare the zeros and ones without counting is to pushing and popping these elements in the stack. That means, wait, let's say this is the stack, and see, first we got 0, so we'll push it into the stack 0, and we'll move the pointer to next we'll be looking at the next symbol in the input, so we'll be looking at 1, and when we see 1 and we'll see we'll see 0, we'll pop the 0. So we pop the 0 from here and move the next. So there is nothing here, so that it will be epsilon and the stack top will be Z naught. So we started at taking the Z naught as initial position, and even after reading the entire string, we reached the state in which we got the Z naught as the stack top. So this string will be accepted. So let's So let's take 0011 as the input string. First we will see whether this string is accepted by not, and then we will continue designing the PDA by writing Q not those equations. So if we saw 0, so we push it into the stack. So here 0, and the pointer will go to next here 0. And if we see 0, again we'll push it into the stack. So here 0, and again pointer moves to 1. And we on seeing 1 and the input and the stack top is 0, we pop this 0. So we popped this, and the pointer moves to the next. And we on seeing 1 and the input and the stack top is 0, we pop the 0, and this stack top moves to the next person, which is in a empty here, so it will be epsilon. And on seeing epsilon and stack top of z0, we came to the initial position, that is the stack is empty, and we also reached by reading the entire input string. So this string also will be accepted. So let's draw the diagram. So let's say Q0 is the starting state, and on seeing 0, and the stack top is Z0, we'll move on to Q1 state, and we push it into the stack. So Z0, and we'll add we'll move to Q1, and we'll add 0 on top of the stack. So first the stack top is Z0, and on top of it we add the 0. And likewise in Q1, if we on 0, if the stack top is also 0, so that means we are looking at the state like this. We already have inserted 0, so but we got another 0. We inserted this 0 in here, so here it's 0. Next again we are seeing another 0, but the stack top is 0. Again we have to insert this. So we'll be in the same state, and we'll insert 0 on top of the 0. And the same goes for 1 also. If we wait, and in Q1 state, if we see 1 and stack top is 0, we pop one element from the stack. So in popping, we say epsilon. Here epsilon means we are popping an element from the stack, and when we pop an element, we move to the second state. So we will know that we have completed one sequence of 0 and 1. So we will move on to next state. So likewise, we'll complete the whole process. Can someone confirm if they understood or not?
Divya, can you confirm?
Yeah, no, it's clear. Thanks.
Sorry, I couldn't manage much on drawing this here.
Yeah, no, if it's fine, can you explain context-free grammar?
Before that, Midul, would you like to add any points to what, in continuation to what Abhinav has mentioned? I think, Midul, there is some connectivity problem from your side. You can just try to rejoin and ping me, okay? Divya, you can continue.
Yeah, no, can you explain context free grammar?
Okay, wait, let me see. Share my screen.
Keep the screen sharing on, Abhinav.
Yes, sir. Ah, so let's take this example. CFJ with SAB as non-terminal alphabet and AB as the terminal alphabet as a start symbol. Following set of production rules. Find reduced grammar equivalent to the above grammar. So let's keep that reduced grammar part aside, and we'll see what this as stands to A as A. That thing.
Okay, Mithul, can you now try speaking? Uh, Still, voice is not coming, Mithul. So you can type in your point in the chat. You can read out for you, Mithul. Yeah. So Abhinav, once Mithul completes typing in the chat, please read out. I'll be on mute. You can continue. You can continue, Abhinav.
Okay. Sir. Yeah, sorry. S stands to A as A. S stands to A. Yes, A. Okay, before that, the terminal alphabet and non-terminal. Non-terminals means they'll be in, you can say the small letters like small a, small b, like that. They'll be small letters and they can be expanded. So I will say in here, so they you can see right the ones he gave in capital letters, yes, SAB, they can be expanded to ASA or B or small b and epsilon because they are not terminals. Because and they can be expanded infinite number of times using the terminal alphabets. And when you see B, we can't expand B because there is no production rule which expands small b tends to like that. So when we reach B, we just reach there and we can't expand the production rule. And we S tends to ASA means we can replace the capital letter capital A and capital B capital S using these symbols at any given point of time. Like that, we don't have any replacement characters for the small a and small b. That's why they are called as the terminal alphabet and non and capital letters. These are called as non-terminals. So these are the production rules he gave, and using these rules we'll have to expand in order to get a string. So let's S tends to ASA. So first we'll replace the left side A. Here A is expanded to B and B tends to B or epsilon. So we can replace A with a capital B and the capital B can be expanded to small b or epsilon. So the string will be like that. So A is replaced with B and S A. Again B is replaced with small b S A and S can be expanded to either ASA or AB or B. So let's take as B as example. So S is reduced to B and A is reduced to capital B according to the question. A is reduced to capital B and B is again reduced to B, either B or epsilon. Sorry, here. So B and here epsilon. So this is the final string we got by using these set of replacements here. So by using them, we generate the context grammar. So yeah, can someone confirm if they have understood this? Else I will explain again.
Yeah, no, it's clear, but it's fixed up. No, you can explain like a power and b power 2n like that by considering a power and b power 2n, and you can perform context free grammar if
Sorry,
it's valid.
I didn't get the question.
I'm asking like if you can, how can we construct context free grammar for a power n b power 2n?
I think I can't do that because the context grammar. Wait, let me see on a question, example like that. I think I can't do that. Sorry, I swear. Yeah.
Yeah, sure.
You can move on to the next question, Divya. Or you want to change the subject, which Abhinav is willing to say?
Yes, I'm sharing the question message. Bye.
I'll just be back. You can run the session till you want. I'll be back in some time. Okay. Vinmay is there if you need any help.
Yeah, okay, sir.
Hi team, this is Mithun.
Hi, Mithun.
Hi, Midul. Your mic is
Yeah,
working
actually
fine
my
now?
mic is not working. Yeah, I've changed my mobile now. Okay. Uh, is there any doubt in PDA?
Guys, Midul here to uh, clear our doubts in PDA. Anyone having doubts in PDA? Abhinav? Abhinav?
Yeah,
Yes,
someone
Uh,
yes,
asked
Chandra.
about tuning mission.
please stop sharing your screen for a while.
Sorry.
When, yeah. Yeah, Midul, you are saying something?
Yeah, someone asked about tuning mission.
Yeah.
Yeah.
You want to explain that?
Yeah, yeah.
Yeah, just
Tuning
go ahead.
mission. Yeah,
Yeah,
tuning
continue.
mission actually
Awesome.
is used for
Midul, you
Okay,
continue.
mathematical
చెప్తాను
model.
వస్తాను.
Yeah, yeah. Tuning mission we are going to use some stack type, but we are going to surround that stack with some blank symbols. Uh, while using tuning mission, we are going to use some different operations compared with PDA. In PDA, we'll just use push and pop. Where when compared to tuning mission, we are going to traverse the string. While traversing, we will tell that if it is accepted string or not. Tuning mission, we are going basically we are going to perform two operations: right operation or left operations.
Divya, please acknowledge you are able to understand Midul what Midul saying.
Yeah, it's understanding my. Let him continue.
Yeah, okay.
Okay. Let me share my screen. Is my screen visible?
Not yet, Midul.
Yeah, it's visible.
Yeah. In tuning mission, we use a stack. When it comes to tuning mission, linear type data structure, and in between we are going to do right operations. When we found same symbol, we are going to perform right operation. When and if a new symbol new state, we will use a construct. Let us take a string like a b, which is a power n, b power n. we found when we traverse A, we change our state from Q naught as it is a new symbol to the mission. We will change our state Q naught to Q1 and we will perform write operation. Actually, it is very hard to draw in paint. So as when we repeatedly traverse the same symbol, we don't change our state. So n number of years comes in our string, we will be at Q1 only. Whenever we found a new string, then only we will change our state from Q1 to Q2. From there, if we found any new symbol, then we will change our state, or which symbol already is in our string like A. Then we will come back and we will perform write operation. At last, whenever we found a blank symbol in this box, we will set that our grammar is acceptable by tuning machine. Hello.
Yeah, Mithul.
So PDA is used for a type 0 grammar. Hello.
Yeah, Midul, you can continue.
Yeah, yeah. Push down automata is used to tell that if grammar is acceptable by any mission or not by using push down automata. So in general, we can tell that PDA is used for repeated characters like A power n, P power n. There should be some sequence to accept that grammar. Then only PDA will tell that based on the stack, if the stack is empty or if it contains some starting symbol Q naught, Z naught, stack symbol Z naught. Based on that, we will decide that the string is acceptable by mission using PDA. That is a general about PDA. In tuning mission, we will accept a grammar by using blank symbol. Whenever we encounter a blank symbol in our grammar, then we will accept that grammar.
Uh, Guys, any doubts what Midul explained?
Yeah, hi, Mithul. I had a doubt. Like, in case of the Turing machine has only yes, yeah, then what will be happen?
If single string is there means we will write a loop on a single state. Like we will take starting state as Q0. Whenever we encounter A, we will move to Q1, and we place a recursive. We will be at Q1 only recursively. So we will get only finite string, right? 3 A's or 4 A's. After completion of A's, we will move to left and we will place a blank and we will accept the grammar.
Yeah, Mridul, I got.
Can I draw it?
Thanks.
Can I draw a
Yeah, sure.
mission
Yeah.
mission diagram? We place a uh, recursion.
Please share your screen, Midul.
Yeah. So forgot about this. I am explaining in this part only. So the doubt is a power n. When a language contains a grammar like a power n, so in initial state from Q0 to whenever we found a, we change the state from Q0 to Q1. After that, n number of years, the mission should be at Q1 only. Some finite input, it will encounter blank in tuning mission as it is bounded with the blank and blank. So whenever the head encounters a blank symbol, then it will accept it. Is it clarified, Divya?
Yeah, Mridul, I got it. Thanks.
Divya, can we move on to the next question?
From my side, is only
Okay.
guys. If
Uh,
anyone had any queries, you can ask him.
yeah, yeah. Anyone, you have any queries or any doubts? Midul and Abhinav are here to clear our doubts.
You can change the subject to change the subject.
Yeah, yeah. And Abhinav, do you want share anything?
No, when my
Okay. Midul,
Yeah, nothing.
do you want to share anything?
Yeah, don't think that a flat is a difficult subject. Relate it with some real-time examples around you. It is easy to understand that. So based on your definitions in our textbook, you can easily construct a grammar or a state transition diagrams. And minimization is important topic in flat. Minimization of a grammar.
Okay. Hi Madhuri, you joined just now. Do you have any doubts regarding the subjects?
Yeah, in flat, are you clear in sixth unit, Divya? Sixth unit.
Uh,
No, I mean,
complete complete.
I took it choice. If it's fine, you can explain it.
Yeah, yeah. The terms that are present in definitions in sixth chapter are easy to understand, but the terminologies are new to us actually. P gram, P complete, P class, NP hard, NP completeness. Yeah, yeah,
By listening
yeah,
these names only, I just got
yeah, yeah.
clear.
I will tell. I will tell about that. So the main era of solving a problem, like real time problems,
Yeah, can you
will be
explain it clearly?
yeah, will come in this chapter, NP completeness. So if you write a deterministic a grammar or a deterministic solution for any problem is called P class problems actually. P class problems. How to relate it? So in Java, you were going to search a element, quick sort or a merge sort, right? In that
Yeah.
we are searching. Keep it simple. Searching a element in an array. So it is very hard to find the element in an array of a huge array of 100. Size. And actually, for any problem, if you write a deterministic algorithm or a deterministic mission or a grammar, then it will come under P class problems. And in other case, it is called as a NP problem, non-deterministic problems. So in researchers will define that anyone in future will solve this problem so that they will get a solution. They'll find a solution, then it will become a P class problem. So the scientist, one of the scientists, Cooks, defined that P is a subset of NP. That means all deterministic problems, uh, uh, any deterministic problem that is once upon a time it is a non-deterministic problem until anyone researcher find a solution to it. In NP problems, we are having two types: NP hard and NP completeness. If you write a
Yeah,
algorithm,
if it's fine, you can share screen and you can explain. Then it's really
yeah,
clear.
yeah. Wait a second. So consider this is a class of containing P problems, and this is a class of NP problems. That means the problems that are not solved yet are called NP problems, like non-deterministic automata, which comes under NP class. So whenever a non-deterministic problem is solved, then it will be in the set of P class problems. So in NP we are having two kinds of problems again. One is NP hard, another one is NP completeness. So writing a deterministic algorithm for a NP problem is called as NP hard. Whereas if you define a deterministic automata, that means we can say that giving certain input, so the mission definitely goes to that state and it will move next to another state. Like that, w- if we define something, then it will comes under completeness, NP completeness problems. So those are solved problems actually. So few scientists worked on on this subject, and they defined that in future uh, they said that all non-deterministic problems can be solved and they are equal to p that are solved. That means these two will become same, become one complete one circle. NP is equal to p. Are there is there any programs not proving that NP is equal to P? Any theorem, Cook's theorem in your syllabus? Satisfiability theorem. Divya,
Yeah,
are you having that topics
yeah,
or just
but didn't remember that much.
check your syllabus? Abhinav, you can tell anything. I will check your syllabus also.
He texted like Midul say about satisfiability theorem. Do you know about that, Midul?
Yeah, satisfiability. Yeah, some researchers developed a satisfiability theorem as a P class problem.
Okay.
So yeah, they are going to use a satisfiability theorem as a base. So whenever any NP problem, any NP problem that can be transformed into satisfiable, which satisfies the satisfiability theorem, so it can directly comes into P class problem. Satisfiability theorem say that is directly proportional to P. When we transform a NP problem into satisfiability, if we prove a NP problem as a satisfiability theorem, then we can say that this is a we can easily write a algorithm for non-deterministic problem. That means we can define a mission for that.
Uh, Abhinav, did you get the point? Seems he understood the concept.
Yeah, no, it's fine.
Yeah, you guys are having this also.
Yeah, thank you, Midul. And thank you, Abhinav, Divya, and everyone in this session. We have successfully completed the session here. And you guys find this recorded video in the YouTube channel also. You can find the link on in our groups and Telegram channels. Thank you so much for cooperating and your patience, getting clear your doubts. See you guys. Thank you, Abhinav,
Thanks,
Divya, and Midul once again.
thanks, Vinmay.